The native plants of Texas are the only plants for me.
So George Cates is presenting from Junction, Texas, where he works on the farm operations at Native American Seed. With over 20 years of experience, he has conducted native prairie remnant harvests for use in ecological restoration projects. This experience gives him a unique insight into establishing resilient native plant populations across a wide range of conditions in the many ecoregions of Texas.
So this is me. I'm George. I work at Native American Seed here in Junction. I noticed you guys are the North Central Texas chapter of the Native Plant Society, uh, who the whole organization itself has been just instrumental in allowing us to be who we are. You guys have promoted us since the beginning, and so we're just absolutely grateful, and we're very like-minded in that we're all about native plants here, and I don't know if y'all are familiar with the history of the company, but I can kind of do a brief summation of it. It started in Flower Mound. Bill Neiman, my father-in-law, started work at I think he says 19. He was 19 and he borrowed a rake and a shovel and a lawnmower from a friend that he was running the trash routes with, and advertised for total outdoor care in the monthly bills that went out on the trash service. And from there built an installation, maintenance, hardscape, just everything you could think of. And then that eventually turned into a nursery up there in Flower Mountain. And I think he said he had 50 guys working for him at one point. And then along came this drought in the 80s that was so bad that all the municipalities just shut the outdoor water off basically. And it was so bad in some places, like this, you couldn't even flush the toilet in the second story. And so he got to thinking about, geez, what are we doing? This is just dumb, because all of the landscapes that he was installing were dying because they had the wrong plants, from Africa and from all four corners of the world. Uh, and at the time, he was living in Argyle and would drive from Argyle down to Flower Mound, where the nursery operation was. And he noticed that there were all these green plants thriving in bar ditches and the pastures, and started asking the people he knew what they were, and I said, oh, well, those are native plants. And so a seed was planted or whatever, and eventually the nursery was transitioned over to only using native plants. And then the first seed harvest was conducted in, I think, 86, and Native American Seed was born. And so at a certain point, the nursery operations closed, and they moved to Junction and set up the seed farm. And now we have really gee whiz warehouse on I-35 in between New Braunfels and San Marcos, where all of our fulfillment and customer care happens. And so over 36 years, the thing has just consistently grown. And what we're starting to see now is that hockey stick growth in the public's understanding, awareness, and need for native plants. And so what I'm going to talk to y'all about tonight is how to grow plants from seed. I like to fish. And Bill always talks about, if you want to catch a trout, you got to think like a trout. So if you want to think like a plant that's growing from seed, you got to think like a seed. How does a seed work? And but for me, I don't trout fish, I bass fish. And I, from time to time, surprise myself that I'm still good at it at my advanced age. But anyway, seeds are amazing little things. There's just endless generations of potential life, and they're packaged in this stable form where you can put them in a bag on a shelf in a warehouse, or save them under the ice for hundreds of years, and then pull them out and they'll grow. And so the whole thing is, how do you make them grow? We got to understand how they function. And really, in the end, it's not about making them do anything. It's about setting up the conditions in which they can thrive and having some patience. So anyway, here's like a cross section of a dicot, and you have all these nice, fancy words to describe what all's going on in, each particular part. But the reason I show this is so that y'all can see that, there's these layers, and they're protective layers that keep moisture and things away from those vulnerable cells that are on the inside. And so, water has to get through those membranes and touch those cells in order for them to grow. And so here they call, this important piece, they call it the testa. So the seed coat. So when you're working with native seeds, understanding their seed coats is pretty important. So then inside the seed coat, you have the endosperm, which is basically just food. And then you have the cotyledons here. So that's the leaves. And then you have the, like the meristem and then the root meristem. So all those cells begin to divide once they get wet and the appropriate, temperature and light conditions have been met. This guy is an amazing photographer. There's a book, a coffee table book, my wife, Emily, really likes called Seed, and he's the author of it. And I don't know if he's using like a scanning electron microscope or whatever, but you can see here how the seeds have begun to divide and elongate, and there go the little roots out in search of some moisture. But grass seeds are a little different. So, a big thing about growing native plants is that you're going to have a diversity of species. So you're going to want to do wildflowers and grasses. And so it's kind of, you want to understand how a grass seed works. And so most grains, cereal grains are grasses, corn, wheat, barley, oats. And they're what, are called monocots is the, scientific term for them. And so that means that they have one cotyledon. So, basically like a single blade that comes out. And so this is how their seeds are structured. And you want to pay attention to this starchy endosperm and the little components inside there. And I'll talk a little bit more about that later. And we'll actually revisit this slide a little later on. And so most of the native grasses, they'll have all these structures on them. And then you'll see down there where the one that says floret, you'll have the lemma, the on, and the palea. And what we call the caryopsis will sit down inside of that. And so, it's important to understand that, you are in fact holding a seed when you go to plant it, and that you're not holding some other part of the plant. So to think like a native plant or to think like a seed, we want to talk about some of the characteristics of native plants that, make them so attractive for use in a landscape. So here in Texas, our native plants are really resilient. And so you got to think about this in terms of like a geological timescale, that here are these plants that survived out on the landscape long before Scots showed up or rainbird or irrigation of any kind, and they just survived on the landscape with, whatever was going on. And so they also have developed myriad seed dispersal strategies through, the ecological forces that they were dealing with. And they specialize. So we have, endemism and is quite common in our native plants. Like, so, the flora of North Central Texas book, the George Diggs book and Barney Linscomb book, that was my college textbook at Austin College, where I kind of got introduced to native plants in a serious way, is it probably weighs 20 pounds. And I think there's, somewhere in there it says exactly how many species there are in it, but it's, a Blackland prairie may have 400 to 500. And so you have, plants have to do something to stand out to fit a specialized niche. Uh, and our grassland species are disturbance dependent. So fire, drought, and megafauna like herds of bison. So like a good example would be like up there is the boat ark, right? So that's a remnant of its seed dispersal mechanism was those sticky horse apples that I used to like to roll out in the street and watch cars run over. Uh, but there used to be some big old furry thing that would eat that and go on down the road and poop it out, So and they're because of all of this stuff, a lot of them are slow growing, but others, they go real quick. They capitalize on favorable conditions that don't last long. I always think of this one that we have out here in the hill country called 6 weeks grama, and it goes from a seed to cycles its seed and 6 weeks. That's why they call it 6 weeks grama. And there's sympatric. So this was putting this slide deck together. This is a new word I learned. I actually had to go to the Florida North Central Texas glossary to find it. But it basically just means that these plants all prefer to live in a diverse community, and they don't really like to live in a monoculture. And I can attest to that for the 20 years I've been working out here on the seed farm. Things don't like growing. These plants don't like growing in rows. That's for sure. But in general, native plants are just awesome, right? I mean, plants in general are just awesome if you're a plant person. So here's a good example of resiliency. So this is like what the hill country looks like. I believe there's some places up in north central Texas where you can find places that look similar to this, especially on uh, those shallow limestone outcroppings east of 75, just south in between Sherman and McKinney, kind of that way. So this white rosinweed is what this plant is, and Silphium albiflorum. So it's a compass plant, and you plant this seed, and it'll sprout, and it'll have 2 leaves on it for a couple of years, and then the third year it'll finally start blooming. But these silphiums, they're known for growing roots, 15, 20 feet deep, and so that's what the plant's doing from the time it sprouts to the time it blooms, is that it's trying to grow a very significant root system to accommodate for, the climactic conditions. So here's, seed dispersal. So depending on the species you're working with, you need to understand its seed dispersal mechanism. So this is devil's claw. And those seed pods are meant to hook onto the fur of a bison and then travel for, 1,000 miles or however far a buffalo roam. And as those pods dry out, one of those seeds will shake loose and fall on the ground. Well, that seed's got to have quite a bit of protection to travel that distance, and then survive. And oftentimes, it'd have to go through a winter or two or whatever before there were, favorable conditions in the warm season for that seed to do its thing. So when you're trying to grow something, that has this kind of seed dispersal mechanism, you need to take that into consideration that there's going to be some issues with providing, the most favorable conditions for that seed to grow. This one's really cool. This is purple 3-on, and so this is the grass, and this is a wind dispersed seed, so it uses those awns to travel long distances in the wind. And Bill was telling me a story about he ran into somebody's son that he knew that was working on these windmills, and they're 200 feet up in the air or whatever, and they'd have to go out there on top of them, and they'd see all this stuff flying by, on a windy day. And this person had caught some and held it in his hand, and it was seed. So, the seed will travel a long, long way. But anyway, what happens when this one hits the ground or a cinder block? Uh, it sticks in there because it's got a pokey end. And as the humidity changes and the wind blows, those awns will curl up and expand back out, and it produces a rotational motion that'll drill the seed into the ground to the appropriate depth. And then once the soil touches the base of those awns, bacteria and fungi will start working on it, and those awns fall off, and then the seed will sprout. So here's an example of specialization of coevolution, or where plants and pollinators kind of figure it out. This is the state flower of Oklahoma. I think, is that right? Indian blanket, state flower of Oklahoma, or is it paintbrushes? Flower. Anyway, that's the Gaillardia moth is the name of that moth, and for predators with bad eyesight, those guys can live a pretty good life without being messed with. But it's kind of hard to think that you could have a Gaillardia moth without a Gaillardia flower. And I kind of wonder if it goes the other way. So here's another thing, slow growing, people may not realize it, but bluebonnets are a very slow growing plant. They sprout in mid-September. This year they're going to sprout early because of all the rain, and it cooled off like 3 weeks early. So hopefully it doesn't get hot and dry over the winter and they can survive. But we don't harvest the seeds until late May to mid-June, so that's around 260 days. Whereas, most folks are used to growing vegetables. And so you can see here, like if you're going to grow collards, direct sow, 80 days, 95 days from seed, So here, endemism. So here's I don't know if y'all use iNaturalist. If you don't, you should. All right, I'm going to run you through it a little bit. Here on down the road, this is the distribution in Texas of the observations that folks have made of that Silphium albiflorum. And you can see it's a very specific, has a very specific range. But there's like, I don't know how many endemics there are in Texas. They're pretty cool. And so this is an example of sympatric. So this, these native plants, this is the kind of thing they like to do, is just all grow in a big jumble. And they work off of each other, so these are cool seeds and annual wildflowers that are like first things that come up in a buffalo walla and provide some shade, and they're tap rooted, so they're going and pulling up nutrients, putting it in their leaves. They desiccate, fall on the ground eventually, and they keep the soil cool over a couple of growing seasons so that the slow growing native grasses can come on and do their thing. And just being generally awesome, this is some decomposed granite. And in the lower right corner there, that's bluebonnet seeds. And so it's thought that the geographic origin of the Texas bluebonnet is in the Llano uplift. And this is all like, decomposed granite from like enchanted rock. And those soils in the Llano uplift happen to be the oldest soils in all of Texas. And so bluebonnets have been around doing their thing for a long, long, long time. Interestingly enough, if you plant bluebonnet seeds in decomposed granite, they really do well. So if you want to have a bluebonnet bed, go get you some compost and decomposed granite and mix that up and plant your bluebonnets there, and they'll do awesome. But another interesting thing about bluebonnets is that they have this really dense seed coat, and they're highly variable in how thick that seed coat is. So remember that slide I showed had the test. If you cut 100 of these seeds open and measured the width of the testa would be different on every one of them. You probably have a bell curve, but that translates into these seeds being able to persist in the environment for decades, or centuries even, I would imagine. There's a woman works with us, Melinda. If y'all have ever called in uh, on the phone, you may have got her. Her family has a ranch out here at Mountain Home, and I think it was around 2000 or 2001. She said that it was a really wet year, a really good year from September on through to March, and her family's had this ranch out there for like 3 generations, 100 years or whatever. And there was just this explosion of bluebonnets that they had never seen before, just a solid carpet across the whole place. Like blew them away. So anyway, those are the seeds. And so if you're a seed that's that big, bluebonnet seeds are quite big, they're going to have a lot of nutrition inside of there. And so, there's lots of things that would want to eat that nutrition. And so the seed coat and the camouflage is an evolutionary protective mechanism. So, a lot of times we'll get questions about, oh, shouldn't I stratify the bluebonnets? Well, you're taking away all their protection, and so you throw them out there to the wind, and it rains real good in September, and then it doesn't rain anymore until March, and it's 100 degrees on Christmas Day or something. Well, every one of those seeds that you'd scarified would sprout and promptly perish. So we don't really recommend that you do that. I want to talk a little bit about the evolutionary forces that these native plants of ours have had to contend with over the eons. And I think the most important one is probably drought. So here we are on the drought monitor a month ago. State of Texas looks pretty good, unless you're in a few counties. You can see the whole eastern half is looking good there, and that's because when a tropical storm had gone through the month before. But if you go back a year, pretty severe drought across most of the state, and 2022 wasn't much better, 2021 wasn't much better, 2020 wasn't much better. So we had these long periods of very unpredictable moisture availability. And so these plants that are short-lived in comparison to a tree or something, they had to evolve a strategy to survive in that kind of environment. And some of the discussions I've heard, professional folks work at organizations like TPWD and are all into the science of this stuff. They talk about how big a driver drought was and where the forests are located, and that over centuries the forests migrate east and west, from Texas into Louisiana and back, based on long and extreme drought cycles, like stuff we hadn't seen because we hadn't been living on the land long enough. So, and with drought comes fire. So fire is just absolutely critical to grassland species. Keeps the trees out. There's some plants folks think that the seeds actually have to be scarified by fire in order to break their dormancy. Fire is a very valuable land management tool if you're trying to manage grasslands. But the plants, all the blackland prairie plants, are well adapted to it. And then of course you had your megafauna, massive herds of bison, and so they were at a scale that they were an evolutionary force, and so all of our grassland species had to adapt to those pressures and figure out how to survive and capitalize as best they could with that kind of pressure. And of course, pollinators and all kinds of stuff goes on in the insect world it's not really my bailiwick, although, I do appreciate their work and, pollinating our flowers so that we have seeds. We need those. Uh, but the insect interactions, they put pressure on plants to, or the genes of plants, to perform in a certain way. So those that are satisfying the needs of these pollinating insects are the ones that get spread and reproduce. Birds as well. Uh, when I took environmental studies at Austin College, we had the first class was Introduction to Environmental Studies, and like the first story we talked about was the passenger pigeon, and it's now extinct, and how the flocks of birds were so intense when folks got to the prairies so thick that they black out the sun for hours at a time as they were flying and migrating across the sky, and but they were tasty, and folks figured out how to sit up on top of the hill with a board and smack them out of the sky, and the humans just ate them to death, and it ate them into extinction. But uh, what were those birds feeding on? Well, here on the farm, this is the crop pest that we have called the painted bunting, and it regularly takes 20% of our seed crop of this Texas cupgrass. And it's interesting because this grass is an indeterminate grass, and so it is providing uh, seeds throughout the growing season, which happens to coincide with the breeding season for these birds. They come up from South America and go back in the winter when it gets cool. Um, but the adults eat the seeds, but they uh, harvest all the grasshoppers that would be, stressing the grass out, and feed those to their babies. So it's kind of a, I'll give you some seed if you keep these bugs off me kind of thing. And we have a temperate climate. So, we have two seasons in Texas, the way I like to say it. We have uh, hot and we have cool. It used to be warm season and cool season, but so there's plants that take advantage of either one. And so, the vegetation tends to specialize. So here in this landscape, this is the warm season. You can see all the wonderful buffalo grass and curly mesquite and blue grama in the yard there, and blackland prairie species around the edges. And incidentally enough, this landscape was done about 98% with seed. That's all seed did that landscape. There's a few specimen species in there at the request of the homeowner. Uh, anyway, in the winter, it's a temperate climate. So, here, these plants have had to evolve a strategy to deal with a changing climate. And so basically this is the vegetative version of dormancy that, you know, it's how they survive the winter. So basically they just cast off all that vegetation. So anyway, the evolutionary response to these driving forces generated, two strategies basically for sexual reproduction. When I say sexual reproduction, I'm talking about seeds, making seeds. These plants can reproduce a lot of them vegetatively as well. But since this is a presentation about how to grow things from seed, we're going to talk about seeds. So uh, generally speaking, there's these two categories. So high seed dormancy with low to medium seed production. So think about your perennial plants, grasses, and all the cool plants that you can't grow, and you always wondered why. It's because they're, protecting, they have all these protective mechanisms, built into their seeds. And then you have low seed dormancy with high seed production. So think about, lemon mint or Indian blanket, these things that just produce gobs and gobs and gobs and gobs of seeds. And typically, those seeds are very, very small in comparison to the seeds of the perennial plants that have that high dormancy mechanism built into it. So we get to do all these fun spreadsheets here when we're making seed mixes about, we have to use seed counts per pound, figure out how many seeds to plant in a square foot and all that stuff. And then what's the dormancy rate, what's the growth habit of these plants, and put all that together so that when you go plant, one of our seed mixes, you have a reasonable expectation of success. But there's always exceptions. And so we want to know, this basic kind of fundamental information about the seeds that we're trying to grow to begin with. And so, as a if you're a seed collector, if you're going out to prey remnants and harvesting your own seed, it's unlikely that you would ever come across this kind of information. But it's good to know. So you can see here that the seed labs measure for a couple metrics. The one that's really important for this discussion, though, is this here where they say germination and dormant seed. So there's protocols that this Society of Commercial Seed Technologists have. Different protocols for different species where they say these are the ideal conditions. And so they'll have so many hours of light at this temperature in a germination chamber for so many days, and then you change it or whatever. And so after it's run that course of 28 days or 21 days, whatever the protocols say, they'll pull them out and examine the seeds, and they'll say, okay, well, we put 100 in there and 21 of them germinated readily. So then what they do is they take the remaining ones, and there's a way to cut them open and stain them with a particular chemical to determine whether the little embryos are viable or not. So anyway, we can look at this and say, oh wow, like we shouldn't expect more than 20 out of 100 seeds to sprout. So anyway, you can see here's kind of the typical trend. You look at something like lemon mint, and you can see here it's got 1,003,540 seeds in a pound, and basically it's just amazing when you think about that pound of lemon mint seed, basically you could fit in your hands. And so there's 1,000,000 plants that fit in the palm of your hands. But in a 4-inch pot, you might get lucky if you can carry 8 of them or 6 of them in your hands, or a 1-gallon pot. It's, you can, the really strong handed folks can carry 4 of those around. So, this is like the power of seed when you're doing ecological restoration it's just unfathomable how efficient it is to work with seeds. So anyway, you get things like lemon mint, and they say, okay, well, I'm going to make 1,000,000 seeds in a pound. And how many plants does it take to make a pound of seed? Well, I don't know the answer to that question, but maybe 50 or something. So, but they do that realizing that a large portion of those are going to probably not find their way into a place where they can do well. And so it's just like this overwhelming reproductive strategy. And then they say, okay, well, we're going to all try and germinate just as fast as we can so that we can reproduce just as fast as we can. And so that's their survival and persistent strategy. But then in something like Indian grass, well, it takes a long time for a tiny Indian grass seed to mature into a big clump of grass. And so its strategy is well, I'll let some germinate, but I'm going to hold back until it gets really wet, and then those will all sprout. And two, from a temperate climate perspective, so here, this is lemon mint's a cool season plant. So it is growing as a rosette throughout the winter and elongates in early spring while the grasses are asleep. So then it dumps its seed out all over the ground as the bison come through or the fire comes through or whatever, and they want to germinate again in September. Now, Indian grass, its seed production is done, it's starting to bloom now down here on our farm. I would imagine it might be a little ahead up there in north central Texas. I hadn't been that way in a while. Um, but those seeds will fall in the ground by October. Well, the warm season, it ends about that same time. I can remember it being really cold on Halloween up there in Sherman going trick or treating, or freezing our behineies off trying to go get candy. So that seed is going to fall on the ground, and there are no conditions that will present themselves under which that plant can establish itself until at least the following spring. And so it's critical for the survival of that species that those seeds can overwinter. But like I said, it's not always the case. So here you have a prairie parsley. It's perennial, uh, germination of 2%, dormancy 97%, and then you have bluebonnets. It's an annual plant. In this particular batch, 63% of them are trying to sprout. So some of this can too be about like how long you've stored the seeds or how long they set out in the environment before they're ready to go. So here's a grass, a perennial grass, Texas cup grass, and you see the majority of it wants to sprout readily. And then you have cane bluestem doing the same thing. And we find that a lot of the mid-height grasses do this. So this is things like cytochgrama and basically anything in our midway mix. And these are transitional grasses. Some people call them indicator grasses. So they're indicating that there's a change afoot. So either the condition of your pasture or planting or prairie area is in decline or it's in recovery if you're starting to see a bunch of these. And here I have gay feather. And it's one that should be all dormant just because of how slow it grows. But it's such a drought tolerant plant, I believe, that it wants to just get going and start building that root and get it as deep as it can. And if you look at the seed coat on gay feather, it's like real paper thin. So obviously, it doesn't take as much water to get it in there. So anyway, knowing a little bit about how the plant's trying to function in the environment will give you clues about what to expect when you go put its seeds out there. And so if the environment is not the kind of environment that's conducive to that plant, then you should probably pick a different plant. So anyway, here's the steps for growing stuff from seed. Run through these. So you got to pick a good spot. And when you look at that spot, it's going to tell you some things about what wants to grow there. Okay. And so then you pick things that'll grow there that meet your criteria of what you're, wanting to see. And I'm going to show you some tools on how to pick what should be there. Because the better you match a plant to the site, the better the long-term outcome will be. Like, so for example, I have a north-facing slope under an oak tree and it holds water all the time and I want bluebonnets to grow there. Well, the expectations and realities of that are butting heads to say the least, right? So bluebonnets don't want to grow with wet feet in the shade. They like sun and all that. So then you want to acquire your seeds. And so I put this in here for a reason because a lot of times, people say, oh, I just can't get this little blue stem to grow, or I can't get this species to grow or that species to grow. And I went and picked the seeds myself, and so, oh, well, when did you go get them? Oh, we went and got these big blue stem seeds like in January. And, if they're still on the plant in January when they're supposed to fall off in October, there's probably a reason why they're still on the plant. It's because they're empty. All the good ones, the plant knows to let those go. So you definitely want to evaluate the qualities of your seed resource before you go investing all the time and energy to do the rest of this. So then you're gonna, do a little bit of design work, right? You want to figure out what are my goals and objectives with these seeds and these plants, and then don't design contrary to that. Don't set yourself up for a failure. And then when you're preparing a site now, this could also be pots. When you're preparing pots to put plants in, you want to be thinking about uh, not necessarily weed management, but definitely like soil health and tilth. And I've got some slides on this on down the road here. And how do you install them? Be sure that that you're doing the right way for whatever the site is telling you that it requires. And then they're going to grow at some point. And so, big thing these days that we run into is that the hardest part about growing stuff from seed is invasive species. Uh, and unfortunately, we're not really in Texas allowed to call them invasive. The only people that can call them invasive is Department of Agriculture. And it's because there's this there's a website called texasinvasives.org. It was kind of an offshoot of the Lady Bird Johnson Wildflower Center folks trying to educate the public about, the things that shouldn't be in landscapes. And, they put stuff like Bermuda grass and Johnson grass and Klein grass and all these important, improved uh, pasture grasses on the list. And, you know, Bermuda grass is like a $8 billion a year industry in Texas or some outrageous, thing. And so we can't have that be an invasive plant. So, we've here reverted to calling them aliens, Uh, nobody likes aliens. So anyway, the thing is that when you plant one thing, everything else is a weed, right? And so when you're planting a bunch of things, it's kind of important to figure out what the real weeds are going to be. And I promise you, you live anywhere in Texas and you disturb the soil, there's going to be the potential for non-native plants to show up. And so, we'll get questions all the time like, oh, can't I just, throw these seeds out and then they'll just take over? Well, that's not quite how it works. So, uh, preparing the site and then encouraging your natives and discouraging the things that you don't want in there uh, as your slow growing plants are establishing is kind of important. And so part of that is about the water, and so we'll talk about that here in a minute. And then once it's established, how do you maintain it? And basically that's like you have to be the ecological forces, the evolutionary forces that those plants require. And so this means you got to be the buffalo man, or be the fire, or be you got to help those plants cycle their biomass and kind of mimic the conditions that they evolved in. So, in my mind, anywhere is a good place for native plants, but some folks have other ideas. This particular project, they made it amenity on this trail, this walking trail, all around the campus, was planted in a mixture of native grasses and wildflowers for folks to go take a stroll when they're stressing out about their midterm exams or whatever, and go catch a break out there and connect with nature. So. So read the land. Okay, well, what story is the land trying to tell me here? Well, it's like really thin, rocky soil. It's got some slope to it. This is an upland site. This is not somewhere I should try and grow bottomland vegetation, right? So, this is not the riparian, right? This is something that very drought tolerant plants would want to grow on. And it's in central Texas. So we're going to have, some mild, cool, wet winters. And so, things, ephemeral plants that survive on stuff like that, like bluebonnets, would probably want to grow here. So if you're putting, your energy into growing stuff in pots, you want to be sure that when it's time to get them out of the pot and put them into a place to live, because that's the whole reason why we grow things in pots, is so that we can plant them somewhere where they can live. Is that you want to be sure that you've, identified the correct site conditions for them. And so, here's some dichotomous site conditions. If it's flat, it can't be a slope, and if it's short, it can't be tall, and if it's wet, it can't be dry. And so there's just some things to think about. But if you want to catch a verbena, you got to think like a verbena, you know. So this is up in our equipment yard, and this was we got a 5-inch rain about, I don't know, 4 weeks ago, and this was a couple weeks after that, and verbena, it's not like that verbena sprouted and then grew to that height and bloomed in that short a period of time. So that plant was just hanging out inside of that aluminum pipe uh, in the doldrums of summer in Junction, Texas, where the ambient temperature is 106 degrees, and inside of that pipe, it's probably over 150, 160 degrees inside of there. But there's just enough shade to keep the intense UV off of it. And as soon as the rains came, it said, okay, well, I can make some seed off of that. So, there's a species there that if you want to grow that in a landscape, you better find a similar spot to put it in. And so, this particular landscape has some rain gardens in it. And so that kind of makes this, where if you have a rain garden, it's a low spot. So in order to have a low spot, you're gonna have a high spot. And it's in the middle of a parking lot, so quite warm. But this is obviously earlier in the year. Anyway, you just want to match your, species to the site conditions. So here's some really good resources for species selection, based on site. So I'm going to run through 3 of these. I use iNaturalist and Google Earth extensively in my work, and I use Google Earth because this outfit, UC Davis, took all of the information from the Web Soil Survey and created a KMZ layer that you can load and quickly navigate in Google Earth. So I use that for mapping projects and everything anyway, so it's convenient for me to have that data in there. You can do the same thing if you're not proficient with Google Earth. You can get there through Web Soil Survey. It's just as it's called ecological site data, and in order to get it, you have to like build this whole report inside of this app, whereas it's like 3 clicks away in Google Earth. So let me show that. We'll start with Google Earth here. So I can finish this. So this is the neighborhood I grew up in. So here you can see that it says that, here's your soil type. It's very dark clay. Here's its name. And then this little guy here is telling you what its ecological site is. And so if you click that, it'll take you to this whole ecological site it's all USDA NRCS data, and basically it's associated with soil surveys. So every soil site, every soil type, and every different precipitation zone, has these characteristics. So you can learn a lot about what the land is. But I go to this ecological dynamics section to get an understanding of what's the ecology that is going on here. And so it'll give you some really good information about how that particular ecological site functions. So think, how did a Blackland Prairie function? And so there's a bunch of information here. And then how did it get to where it is today? And how do you get it back? So on and so forth. So some good land management information. But at the very bottom of all this, here's what they call the historical plant community. So this is about the best jumping off point you can start with. It's like, here's some real information about what grows in a Blackland prairie, right? So, if you have that soil type in the spot that you're trying to plant some native plants, it would behoove you to at least pick a few off this list. And then here's a link for each species. It links over to I'm sure y'all are familiar with this database, where you can get some, distributional information, some links, and some more information about those species. So that's one good place to go. And then so the thing about that USDA NRCS data is that it's all focused on, plants that have range value. So, basically, would a cow eat it, or does a donkey eat it, or a sheep eat it, or can you turn it into livestock, is pretty much what they're talking about. So, anyway, it's my neighborhood there in Sherman. And here's Austin College, who recently has, installed some Blackland Prairie around their new science building there. And so a lot of these observations, I would imagine, are, students. But what you can do is go here to iNaturalist and you click the explore thing, and then there'll be a tab to click the map, and you go to the map, you type in flowering plants. And then you can go through this list of, these are observations that a human being has made of a plant growing in situ, and you can kind of get a sense of, well, what are the weeds I might have to mess with, but also, what are the native plants that can persist here, right? And so here's, some things to think about. So a lot of times, we used to have to go to like old railroad tracks or fence lines or cemeteries or something around a place that we were going to be doing the ecological restoration on to get a sense of all the plants that didn't make it onto the USDA list because they didn't have any forage value. So anyway, you can also type in grasses. Go look at the grasses. What are the grasses I'm going to be dealing with? So anyway, just a really, really nice tool for trying to pick the right stuff. And then of course I'll do a little shameless self-promotion here. This is on our website. If you go to our website, we have this nice ecoregion map. And so you can click your ecoregion. So Blackland Prairie, North Central Texas. Now, let me blow this up here where y'all can see this. Okay, so now narrow your search. Okay, so I'm in the Blackland Prairie and I have, my spot is full sun and it's clay and it's a medium thing. And then I'm really into pollinators. So as you're clicking through there, the site is narrowing down to things that fit that criteria. I want stuff that blooms in the spring that's short. Well, here's some things you can consider. And so if you go into, our mixes and you go to contains, now you can see, some stuff about individual species that would kind of meet that criteria. If they don't, populate readily right here for you. Okay. I think that covers those resources. Let me jump back into my PowerPoint here. And then, of course, if you want some more information about plant characteristics and so on and so forth, the wildflower.org in-pin database is a really good one. And it was cool to see the one that y'all showed, the backyard habitat thing, the backyard national park. So that's like the citizen science thing is really cool. If you can tap into it and get some hints about what, is persisting and what you can do there. So let me continue from here, play from current slide. Okay, so seed collection and acquisition, we talked about this a little bit. That's Fisher. He's about, that was the last time we did a big prairie harvest at this particular remnant. It was like 2018. So
That's me.
he would be about 2 in this video here. And so you can see there's Papa in the background with Grandma and Granddad, and we're staring at our thumbs. And so what we're doing is we're stripping seed off this little blue stem, and we're looking for that caryopsis down inside of it. Be sure that it's going to be a viable seed harvest. So a lot of times, under really drought stress conditions, the seeds will bloom, the plants will bloom, but the seeds don't fill. And so you could go out there and waste a whole month gathering up a bunch of compost, basically. So children mimic their people that raise them. And so that's Fisher's checking out the seed quality. He said he approved. Go on to the next slide here. But there's other clues that we use. So the painted buntings are one. If they're out there stripping seeds off the plants, well, there's seeds to be had. These are harvester ants here. And they, were at one point common in the Blackman prairies, but they're, the way they survive is they go harvest seeds off the ground, or sometimes they'll get up in the plants and they carry them back to their central nest there, carry them down in the hole, they shuck them out, and they masticate the germplasm, the insides of the seeds, and then feed that to a fungus, and then they carry the empty husks up out of the nest, and they have these neat and tidy kind of trash mounds around that central hole. So when seeds are ready and falling on the ground, these guys are real active. And so if they're carrying seeds around, they're falling off the plants, and that's probably a good time to get them. And they typically don't pick up empty ones. They know better than to do that. Another cool thing about those ants is that they're, they comprise like 85 to 90% of the diet of the Texas horned lizard. So the horned lizard's kind of like a indicator species that things are going well habitat wise, but they're solely dependent on those ants. So if the ants are eradicated from the landscape, so are these guys. But those ants can't persist without the seeds of native plants. So the plants have to make enough seed that they can share with the ants. But sometimes the ants will carry them down in there, and the seed coats are so hard that they can't get the endosperm out of there. And so then they carry them back up out of the mound while they're still full. And so they become a dispersal mechanism. And, they're not 100% efficient at gathering things. And so they'll carry stuff around, work as a seed dispersal mechanism. So anyway, it's important to check that you have all these requisite pieces of your seeds, and they're teeny tiny little things. A lot of them, like imagine a mechanical pencil, and you click it a couple times and then break that off and put it in your hand. That's how big some of these seeds are, or I should say how small some of them are. So we use all kinds of tricks, loops, microscopes. We'll squish them between our fingernails to see if they'll leave an oil stain on our fingernail, just to see if there's life inside of them, And you can do a pressure test where you poke on the back of it with on the round side of the seed with like an X-Acto knife or a pair of tweezers, and if you can feel something hard inside of there, uh, you probably got a good grain. But some of the grasses are a little tricky, like switchgrass. They'll have a pretty hard seed coat you have to crack open. Eastern gamma grass, buffalo grass, you gotta just get in there and find the life inside of those seeds. And, sometimes you have to destroy a few to figure out what you're working with. So design, don't shoot yourself in the foot from the get-go. So here the objective was we're going to restore some coastal prairie, but what we're going to do is we're going to put a nice line here of Bermuda grass sod out on this landscape, 8 months before it's ready to be seeded, and just let that stuff go wild. Wasn't a good design here. They wanted to plant buffalo grass on top of 4 inches of really coarse, hot compost that got laid on top of highly pacted, caliche, and wasn't stirred in or whatever. And it's on a slope. There's no erosion blankets specified. There's no hydromulch specified. So nothing to armor the soil in place. And so the first, rain just washed all the seed out of there. And then you wind up with a failure. And that's no fault of the contractors. They did exactly what they were, told to do, is designed to fail. Same thing here. Like normally, so the green blankets underneath there are called turf reinforcement mats, and you would typically lay those on top of a seeded area, and the grass will grow through that, and then lock into it, and then it reinforces the vegetation so that it won't erode. But in this instance, they put that down on top of bare ground and then blew seed and compost on top of it with a pneumatic blower, and the river promptly rose 20 feet and just wiped it all out. So it works in a greenhouse, but not in the real world. So just don't shoot yourself in the foot. So this is my co-pilot on the golf cart out here, Lucy. She's testing out the tilth of the plowed ground there. So lots of different ways to prepare a site to receive seed. And it's, you wouldn't go plow caliche like this. This is good, rich alluvial river bottom dirt that, can handle some of this. So, there's tillage. It's hard to till something that's compacted like this. So if you ever work over a site, that has clay in the soil when it's wet, you're basically making pottery. And, these are, while the seeds are magical, they're not magic beans. And, those tiny little roots can't grow in bricks, as much as they'd like to, they just can't do it. And so, you need to kind of assess what if you're gonna have to do some remediation of the soil tilth there. So here's one way. And it's basically just like scarification, where you're busting that compacted layer up, and then you want to add some nutrition. Now, native grasses, they don't typically respond to like nitrogen fertilization. It's all about the microbes. And compost seems to be like the best way to take care of native plants. So high carbon, low nitrogen, high in mycorrhizal fungi and beneficial bacteria, and well finished compost, like where it's not steaming hot. And so this is how you would kind of work a spot over. So incidentally, that is all composted seed chaff from our harvest. After it runs through the seed cleaning plant, we'll go down on the farm and compost it. So here you have little scar fires scratching up the soil, making a way for those nutrients to get down in there. This is our plot of curly mesquite grass that I don't know, 10 years old or something. And this was early on this spring. We did this, and it really revitalized the plot and helped it take off. Site prep can be a lot of different things, and one of the biggest issues a lot of folks have is the weeds, so to speak. So here's a site that is covered in Bermuda grass, and you see how dense the thatch is, and there's just there's no way that you'd establish a prairie just throwing seeds into that. So sometimes you catch cancer and you gotta have a little chemotherapy to take care of it. And on this particular site here, this is actually a treatment of cool season grass in the early spring. So it's, we have a lot of invasive grasses that are cool season in Texas. They're starting to get worse, like Italian rye, these brome species. They just form these super dense colonies, massive seed production, and suck up all the moisture and then desiccate in the summer and don't function well with trying to make room for native grasses and or wildflowers. And so at this particular site, they had Bermuda grass and Johnson grass, old world blue stem, and these cool season things. So the site prep, was ongoing for a couple of years while the house was being constructed in order to prepare the thing to have an appropriate, seed bed that was clean as we could get it to establish stuff from seed. These leaves are an issue, so a lot of times, things grow slow in the shade anyway, but when you have, pecans, hackberries, oaks, sycamores, all these things drop their leaves and they're full of tannic acid and these other chemicals that are like allelopathic, and so they inhibit the germination of other species. So you wind up with like spotty vegetation under these trees. And so if you're going to want to work with seeds under trees, you're going to want to get that stuff out of there and do some remediation on the soil with compost tea or dusting of compost or molasses or something to try and work on those tannins that have built up in the soil there. And so then, you get your site clean and get your soil tilth together, and then you put your seeds out. And you can see here, we're throwing them on the surface. Those are bluebonnets. And they're not going to grow just like that. They got to get raked in and buried. And the, typical rule of thumb is that you don't want to plant a seed more than twice deep as it is wide.
Yeah.
So basically, if you can get dirt on 3 sides of these things, you're doing pretty good. And so there's no real rocket science to planting seeds in the landscape. They just have to touch the earth on 3 sides and then have all the air squished out from around them. But they're not going to grow in a bag. I'll tell you that. They're not going to grow on a shelf. The only place they're going to grow is out in the environment. So get them out there. That's a milkweed seed there, the Indian grass. After so many years of doing this, I know them all by sight. It's weird. So then they'll need to be, you have to firm the soil up. So, just imagine the hooves of a million bison, right? That's basically what's going on is bison come tear up the land, knock all the seeds down, and then their hooves would pack them in. So you got to be the buffalo. A lot of people, miss this step, and there's lots of different ways to do it. You can, use a board with a couple holes in it and a piece of rope and just go stomp it in. You can get the grandkids out there to hop up and down on it. You can drive over it with your golf cart, your truck, your whatever. You stomp it in yourself. You can get a tamper from the hardware store, tamp them in. We've done it all different kinds of ways. But taking the air out of the soil and getting the seeds packed in there is really beneficial. Keeps the soil from washing away too. But there's, we use specialized equipment in our restoration work. This is called a no-till seed drill, and it's meant to slice open a tiny furrow, and you can install the seed at whatever depth you choose. You can change these bands out here to allow the knives to penetrate deeper or shallower, depending on the size of the seed. We typically go 3/8 of an inch. This is what that looks like. You can see the grass seed there. Go back a slide, and then these rubber wheels down here at the bottom, they'll pack a furrow that is like a V-notch, and so it'll catch dew and rain. And when the seedling sprouts, it's protected from the wind. So these machines are super effective. We'll put 3 of them to work, and we go plant 50, 60 acres a day. It's pretty satisfying work. But so what does it look like from, start to finish? This is that same landscape we saw earlier, and the outside was vegetated the previous year growing season, because the interior here was meant to be a lawn, and it was covered in Bermuda grass, and so we spent an extra growing season treating the Bermuda grass to make sure that we had a clean seed bed to go into. So the site gets raked, seeded, and then we use these things are awesome. They're Curlex wood fiber, and they're a loose mesh, so they cool the soil down. They let the grass sprout through it, and they help retain water. So here it is, 100 degrees, July 20th. So after a week of watering, 4 times a day for like 5 minutes, the germination begins. So we keep that up. Then at 16 days, the grasses are tillered. So now we cut back to, once a day, but for 10 minutes or something. And of course, if it rains, then you don't water, and then in 35 days, you pretty much turn the sprinklers off at this point. Then you can go get your knee pads on and start pulling weeds. But if you want to grow it in pots, you can ask Brants how much work it is. Native plants, man, and I'm sure there's plenty of y'all on the called that know exactly what this is all about, and you want to take on the best strategies to be sure that you get the best result. And so you want to think about, okay, this is a coastal prairie plant that grows in really basic wet clay. A heavy peat mix that's real acidic is probably not going to yield a good result. So you want to match your soil blend. You want to make your soil blend to be, to have the things that native plant would encounter in its natural habitat, and under the right kind of same kind of conditions it would be growing in naturally. We like these 200 count plug trays. They're pretty handy, especially when you're working with stuff that doesn't want to germinate and you're trying to make a production plot. So what you can do here is, you can get them to germinate. And then if you need to bump them up, you can bump them up and then into a uniform, tray at 36 Anderson bands or something. But this is typical, it's never 100% with these things. And it's interesting, you'll take the transplants out of these pots and then set that pot aside in a greenhouse, for a year and forget about it. And then you take it outside and it gets rained on, all of a sudden everything else that's in there sprouts, So there's lots of different things you can try. This cold wet stratification seems to work well on a number of things that are typically have a high dormancy rate. So we use it in particular on antelope horn milkweed and green milkweed. Those plants are what they call hydrophobic. So or the seeds are, and in fact, like in World War II, there was like a bunch of folks in the Midwest would gather the milkweed fluff out of the cornfields and send it to the places where they'd make life jackets out of it because those fibers repel water. And so they'd float. Those life jackets would float. And so that same, chemical structure is all over these milkweed seeds. And so they just, repel water. And so the cold, wet stratification does is it helps to, wash those chemicals off and then allow water to begin penetrating that seed coat. So we soak them for 24 hours, then rinse them real good, wash all that stuff off of them. Mix them with a wet, sterile medium. The sterility is pretty important because these things got to stratify for 45 days in the refrigerator, and you don't want to be growing mold or anything on them. You want to put them in an airtight container once they're mixed up. Scarification can be done mechanically or chemically. So there's lots of tips and tricks out there that folks are working on. Hydrogen peroxide, gibberellic acid, all different kinds of acid treatments, and then, just mechanically scarifying seeds. But the thing is, you want to, once you do something like that to a plant, you own it. It's your baby now. You got to take care of it until it can establish itself in the landscape. So, we would only recommend doing stuff like this if you're going to be working in containers to get going. If you're going to go direct sow something, you're going to do better by spending your efforts in site preparation and dealing with the invasive weed species than you are manipulating the seeds to force them to sprout, and then just understanding, okay, is this, am I planting cool season plants or warm season plants? When should I expect them to germinate? It's not about when do I put them out in the environment? It's when are they going to do what they're supposed to do? And what do I need to do to be sure that they have room to grow? So anyway, what happens, if you don't do those processes, you can wind up with really sporadic germination. And so then, you want to bump them up into something where they can, flush out enough roots so that when you go and transplant them and water them in, that they'll be good to go. And so we also like these containers. So this is a Zyzotes milkweed we got growing in there because they like tuberous and they like to grow deeper roots. They're usually used for growing trees for reforestation, but there's a lot of these native plants that really grow a deep taproot. So you have to, have a container that taproot can form in. So, for example, perennial wine cup, some people would call it, or in the literature, they call it prairie parsnip. So it's like a carrot, right? Well, you're not going to do very well in a 4-inch pot because there's nowhere for that root to go. So these are 9-inch containers, and this is switchgrass on the left and maximilian on the right. And you can see that these native plants have a proclivity for producing exceptionally deep root systems, and so transplanting a plug that has that amount of root mass on it is going to be a much more sustainable practice than a shallow rooted 2-inch or 4-inch pot. So you just want to match the container to the characteristics of the plant. That's kind of the point there. Okay, so whether you've got your seeds going or you got your transplants out there, what about how do you establish them? A lot of times what I see is people loving their native plants to death. So this is at that site in Killeen. You'll notice how all of the plants that are really, really yellow, those are all native wildflowers. And all the ones that are verdant green are non-native invasive species like bastard cabbage and armadillo burr clover. And the brown stuff there is all native grass. And so this was installed in early October. And it was warm enough to get the grass to sprout. And so it's very thin soils to begin with. And so they, specified a very rich, nitrogen-rich compost mixture to go along with the seeds on top of this caliche, and didn't scarify it in, didn't make a root zone or anything. Put the seeds out there, and obviously the contamination came in the machine. And so now the site's just covered in all these plants. So they wanted erosion control out of the grasses that are warm season grasses that they planted at the end of the warm season. So they just turned the sprinklers on and they're watering the tar out of it. And they called us and said, "Hey, how come it's not working? Like, what's the deal? We can't figure this out." And well, it's like their expectations were just totally off base there. That they should have turned the sprinklers off and got the weeds anyway. So this is early February, and they got issues. So as it grows in through March, you can see the bastard cabbage starting to come on, and like they're hemming and hawing about who's gonna come take care of the weeds. I mean, nobody can identify them. Meanwhile, if you let that go, the whole thing's gonna get overrun with bastard cabbage. So at the last minute, we swooped in and basically just, took care of it. That's how you take care of it. So you have to be that selective pressure that, decides what lives and dies. And every time we make a disturbance, we like to go put in some seed. Mother Nature abhors a void, and we'll fill it with whatever's most readily available. So we want to provide as much desirable, stuff in the seed bank as we can. There's a picture of the biomass. So, we weeded it and told them to turn the sprinklers off and left. Came back in June, and that's what we got. So, a lot about growing a native plant is giving it what it needs, and it's really not about you. It's about it's about the plants and mimicking the environment that they would normally grow in. So a very dry, caliche, disturbed thing, and boy, look at all the wildflowers just go crazy for it. So once you got it established, you got to maintain it. So what does that mean? It means you got to keep all the nasty stuff out of there. These exotic grasses, improved pasture grasses are just all over the place. Sometimes even like there's other native plants that, are really going to mess with what you're doing, and, may not meet your aesthetic goals and objectives.
Sure.
But somebody's got to be that force to go in there and pull the beggar's lice out away from a standing cypress, and to pull the giant ragweed out, and to pull the mayor's tail out, because that's not what's meant to be there, and to go get the sow thistle back here. So I see it, like this is if you value native plants, then you should value people who are willing to go do the work. So part of maintaining it is the weeds, but then also it's the biomass. You got to be the buffalo. So, things transition from short to tall. Somebody's got to sort it out. Sometimes it's a mess. But I'm telling you, the more fertilizer and the more water you put on a native planting, the more weeds you're going to have to deal with. So this is all, crabgrass, basically, that was in a native landscape that was being over irrigated. So we get a lot of questions at Native American Seed, and by far, this is the most frequently asked question. When's the best time to plant? And I think this comes out of like, the whole gardening culture where, things have a season. You can't plant tomatoes in December because they'll freeze. So these are two Chinese proverbs I've heard recently that I really like. So the best time to plant a tree was 20 years ago, and the second best time is now. One generation plants the trees and another gets the shade. So with native species, they just need to be in the environment, and there needs to be an environment that they can persist in. And if you don't know when that is, you can pay attention to nature and see when those seeds are falling on the ground in nature. Now, if you're trying to do like, erosion control and you're relying on plants for certain things, yeah, I mean, you don't necessarily want to put them out there and think that they're going to do what you need in the wrong season. You have to set the environment up so that when the conditions present themselves eventually down the road, that those plants can do the things. So those erosion blankets and and cool season cover crops and diverse mixes can really kind of help that. But one thing over the years I've found is that it's darn near impossible to plant seed in the mud. So if it's dry, that's a good time. And of course, when the site is properly prepared. Here's another one we get a lot, about zones. And, that's important for gardening, but not so much for native plants. Really, it's all about the microclimate, microhabitats, microclimates of and the site-specific stuff. How much rainfall, what kind of soil, what elevation, those are better metrics. It's interesting. So this hardiness zone, it's these lateral lines, that run north to south, or the zones, segregate north to south. But in where we're at, everything is about rainfall, and it's all east to west. So, the plants, they follow those precipitation zones more so than they do the average low temperature. As you can see here on our ecoregion map, all the lines are running north-south that separate the ecoregions, for the most part. And that's all due to, the receding ocean that is the Gulf of Mexico, and the deposit of, deposition of different layers of stuff. And that corresponds with these correspond with rainfall. Like average rainfall in Junction is like 14 to 21 inches. And in Blackland Prairie up there in Sherman, and it's like 35 to 45 inches a year. It's totally different quantity of rain means totally different, plants. And then plus, there's a lot of these native plants that they don't care about a hardiness zone. So look, here's black-eyed Susan. It's more about rainfall than anything else, right? So it doesn't care how cold it gets. It'll, do its thing in its time whenever it's supposed to, wherever you put it. So here's some more, how often do I need to mow? So on and so forth. But these are the questions nobody asks that I wish they would. And if you ask these questions and get the answers, if you answer these questions, you'll get better results. And who doesn't want good results, right? That's what it's all about. That's all I got.